Let A be an n by n matrix with entries from a field F. We say that A is invertible if the inverse matrix of A exists. Otherwise, A is non-invertible. There's actually a way to test the invertibility of A without actually trying to find the inverse of A. And the condition is this. A is invertible if and only if there does not exist x in Fn, x not equal to the 0 tuple, such that Ax is equal to 0. So the condition is this. You look at this system and you see if there's a solution that is not identically 0. Clearly, the tuple of all zeros satisfy this equation, and such a solution is called the trivial solution. Every other solution is called a non-trivial solution. So what this is saying is A is invertible if and only if there is no non-trivial solution. Now, this condition here doesn't really require F to be a field. And so we can define the notion of a singular matrix as follows. We say A is singular if there exists X having at least one non-zero, such that Ax is equal to 0. And a matrix that is not singular is said to be non-singular. So if A is a matrix with entries defined over a field, the notion of singularity and non-invertibility are the same. So such a matrix is invertible if and only if it is non-singular. Now let's look at an example. So we're going to look at the matrix A defined over GF2. And we want to determine if this is invertible. What we'll do instead is to determine if it is singular. Now to determine if this is singular, you row reduce it to a matrix in reduced row echelon form and see if there is any zero row. So this is over GF2. What I'm going to do is, the first thing is to replace row 3 with row 3 plus row 1. That will give me 1, 1, 1, 0, 1, 0, and 0, 1, 0. And now I replace row 3 with row 3 plus row 2. I get 1, 1, 1, 0, 1, 0, and 0, 0, 0. And there's no need to go any further because I know that this matrix is going to be singular because x3 is going to be a free variable. And in particular, if I take x equal to 1, 0, 1, Ax is equal to 0, 0, 0, which you can check. So A is singular and A does not have an inverse.